listening to yet another episode of Smash the Bug. I'm your host, Joseph Maxwell, and it is an absolute privilege of mine to take you on this journey of growth, career development, as we all are e-commerce developers in one form or fashion. Our podcast today is the continuation of a two-part series that wasn't originally intended to be two parts, but it really is. So it is one of my favorites that I have done, a sip from the fire hose. It is incredible. Probably remember a couple weeks ago when we started our conversation with Igor Miniailo, from the chief architect for the Adobe Commerce platform. And we are going to continue that here today. So without further ado, let's jump in. So modularity. Is there a couple of rules you can talk to us about that you've learned over the years?
So, sorry not answering your question directly, but
okay.
In software architecture, most of the question, I would say the vast majority of answers for all the questions is kind of maybe framed as it depends. Because
right.
It depends on the circumstances. It depends on the on the answer of who you are. Whether you are a platform developer, whether you are extension developer, the answer might be different. And because when we will be talking about modularity, because the whole idea of modularity related to two metrics, coupling and cohesion. And not a lot of people understand and can define the coupling and how the coupling is different from cohesion. Because usually most of the people consider that cohesion is something good, while coupling is something bad, and you need to have high coupling and low cohesion. But most of the books covering software architecture, usually they never define how to achieve a good coupling, for example. And there might be, and actually in Magento we tried multiple different things trying to achieve good coupling, low coupling and good cohesion. I would not say that all of those initiatives were proven with time and we keep doing our due diligence there, but it's interesting because when we started, you also need to consider that Magento 2 is kind of came through the process of refactoring of Magento 1, and specifically in Magento 1, not a lot of people realize that we have dependency hell there. Because there was no dependency injection,
right.
We had the service locator pattern, so that we dynamically loaded all the dependency on the fly, so that not a lot of developers, even core developers, realized how bad our situation regarding the coupling. And with Magento 2, when we make it, when we introduce the constructor dependency, we only that time when we realize how big the dependency hell is, and that it's actually our major problem. And many people were complaining on Magento 2.0 and most probably 2.1 as well. I would say that we got the performance parity between Magento 2 and Magento 1 probably only along with 2.2 somewhere, because initially Magento 2 was slower, and actually the main reason why it was slower because we use constructor dependency injection, and we had to instantiate all the objects, even so that not all those dependencies were needed for the specific operation. Let's consider product model is probably the best example, because in product model, we had more than 40 different external classes being injected. And you may consider that if the product model is used only, I don't know, for what purposes, to retrieve product name and product price, for example, for the case of the shopping cart, right? only product name, product price, and product image, we now need all these external dependencies. But taking into account that we have a constructor dependency injection, we need to instantiate all those 40 different classes, and not only those 40 classes, but also the external dependencies of those classes as well. So it's recursive, and it's pretty difficult to make it happen when you have such a dependency hell. So that you may understand how many refactoring been done to make this performance parity between Magento 1, which uses dynamic loading, and Magento 2, which we call it internally like honest dependencies and honest contracts. That we are not trying to hide what the external dependency the specific class needs.
Mm-hmm.
So that's why it's interesting the definition of coupling and cohesion, and I'm still not answering your modularity question. I'm just trying to introduce a lot of complexity around this stuff.
And, because there is a lot of nuance, and it's this backstory that matters so much to these conversations. So that's why this is a really good conversation. Yes.
Yeah, and we initially started to make this cyclomatic complexity, and we started to use the static analysis to define the cyclomatic complexity. We even had some, and we defined some threshold. If I'm not wrong, it was 10, and we decided to make a refactoring of all the methods with a cyclomatic complexity of higher than 10. Because usually it was a good sign that we have violation of coupling and so on and so forth. Then,
and when you say cyclomatic complexity, just for everybody who's listening, that's basically how many indents are in a method. Yeah,
so the possibility of leave the method, so that you may consider if you have a lot of different possibility to make a return from this method, it increase the cyclomatic complexity. And like some of the software engineering books, and I believe Robert Martin, they recommend not to use a lot of indents in your method at all. Maybe the rule of the one indent, so that you may have either one if or cycle, but not for example, like if inside of the loop is not considered a good practice. So, and like it's especially when you try to put those those recommendations to extreme, because when you try to make your code to be object-oriented, usually you should not be doing a lot of conditional logic.
Right.
That's why the whole idea of the rule like tell, don't ask is not making a lot of conditions. Ideally you're supposed just to tell. You should be very you should make the comments, not ask the permission to make those comments. And usually this is the whole reason of this conditional logic, when the execution code checks many different conditions, and based on those checks, it makes the decision whether we can proceed further or we need to make something else. Maybe we need to leave the method, and so on and so forth. So that was interesting, but we at some point of time we realized that we can be refactoring Magento too long, but still not achieve not achieve the goal of decreasing the cyclomatic complexity across all the code base, because code base at that time probably was like 2 million lines of code, something like that, which is quite a lot. So that we decided to make the combination of those metrics with there is a well-known metric with not very good sounding name, which is C.R.A.P. So that the whole idea is to have a combination of the cyclomatic complexity and test coverage. And so that we try to use it for some time. And then we try to be even more sophisticated, checking some Git history, trying to find out what specific methods are being updated more than others. So that usually, if you updating the method and there are a lot of bugs being fixed for the specific method, it means that you have a problem there, and you have this churning, and you either need to refactor this method or you need to make the full test coverage of this specific method, so that you have a lack of test coverage. So it was even more complicated. Currently, we have some even more interesting idea of having, but like it introduces a lot of complexity, and it reduces a lot of time being spent for CI/CD execution. That's why at some point of time we reach like 3 or 4 hours being for CI/CD run, and it was unacceptable, because if after even small change your builds need like 3 hours to run to validate your change, it's the time waste, and there's this resources waste as well. That's why currently we are trying to introduce some AI to help us predict what tests need to be run, and so on and so forth. But no matter. So I just wanted to introduce some more complexity. But getting back to modularity and coupling and cohesion, it's interesting because like how to define what specifically should be, and like to talk about modularity, we need to understand or to define, to introduce a definition of what is the code module, because here it might be also some nuances. And if we consider the code module is only a logical grouping of the source code, and maybe, and by the way, maybe logical grouping would not correspond the physical location of the code, so that it might be still physically spread. And specifically in different languages, it might be different, and also it depends on whether your language is functional, whether it's object oriented, whether it's procedural. So there might be some nuances. In PHP and specifically in Magento 2, because we are pretty object oriented system, right? We also inherited this idea of modularity, or the idea of module, at least from Magento 1, with some exception, because in Magento 1 we had those cross-cutting modules like admin HTML, for example, and core. And that was a dependency help, because you may understand that all other modules in the system were dependent on that specific module. So that there were some parts related to admin functionality or back-office functionality, and that back-office functionality belonged to admin HTML module. Same as core, it was, that's why you may consider that it ideally, and again, it depends on how the system is being modularized, because potentially you may consider a system which will follow the idea of the layered architecture, so that there will be just different layers, and there will also like a lot of tendency to have layered architecture like 10 years ago, maybe 15 years ago, so that I believe this is what the vast majority of web projects have started, so that there was a separation between presentation layer, business logic, and database access layer, maybe there were additional layers being introduced, like in Magento, we don't have the specific persistence layer. We have a resource model, which is more sophisticated concept. So that the number of those tiers might be maybe more than 3, but the typical architecture back to those days were 3-tier architecture. Or contrary to that, you may have modules which represent some domain matters. And especially after Eric Evans' big blue book, the domain-driven design became very, very popular, it became another buzzword that a lot of people tried to achieve some domain-driven design state, not especially like moving their like N-tier architecture towards domain-driven design.
Okay.
And it's hard to combine both of the concept. That's like, and one of the reasons that's when we started to make the modularity in Magento, probably 6 or 7 years ago, we decided to eliminate those GUT modules. So that we eliminated admin HTML, we eliminated core module, and we decided to came to the idea of the domain concept. Because the worst thing you may have if you will be mixing the layered architecture on the level of modularity with the main concept. And this exactly what was in Magento 1, like having this admin HTML, which is a great example of the layered architecture. So that was the whole module which was responsible for back office functionality, right? And we started to put this idea on the modules. Even so that we had some GUT modules, like catalog, for example, because most of the modules have a dependency on the catalog. And because such entity like a product is being used everywhere. And, like from the domain-driven design perspective, it's again very, very challenging because, for example, if you want to show the product in the shopping cart, is it the same product which you have in catalog, or it's another type of the product?
That's right.
And this is pretty tricky question because usually the answer is not. And because and that was one of the reasons. And in Magento 2, when we introduced our REST APIs and when we introduced our service contracts, the whole idea of our service contracts was to have only one extensibility point. That's why we thought that it would be great to have only one, let's say, product interface, and to make a third-party developer to make the customization of this product interface. For example, change the product name for some reason. I don't know. For example, make the concatenation with discount price sale 10% or 25%, and so that this change will be applied throughout the project. And that was a great idea. But for example, for the mini shopping cart scenario, we no need to load the whole product entity with this enormous number of product attributes, which for some merchants might be just hundreds. Some merchants might be thousands, especially.
That's right.
Several weeks ago, we had a call with one of the merchants from the auto part details, and they have thousands of product attributes.
Yep.
So that you should not be retrieving all those thousands of product attributes to display the product in the shopping cart. And there are some, and definitely in software architecture, there are answers to all those questions, and and the domain-driven design also provides a possibility to address those issues as well. Having different entities, usually it's called backend for front end, and you may have product entity in the scope of catalog, product entity in the scope of let's say shopping cart, product entity in the scope of order domain, and so on and so forth. Again, as getting back to the first law of software architecture, everything is trade-off, so that there is no silver bullet. That's why usually you're paying with data consistency, or at least you're introducing a lot of complexity for data consistency. To make it happen, to make those changes spread across different domains and so on and so forth. So, and I know I'm dumping too much information, and still I did not come closer to the initial question of yours regarding the modularity. But those all this complexity, and so I am trying to introduce a lot of complexity related to the modularity, and that's why it's very, very hard to define what the specific metrics or what this. First of all, you need to understand what your specific architecture characteristics, whether you're layered architecture, because in layered architecture the definition of modularity might be completely different, and or whether you are domain architecture, because potentially as a third-party developer you may be completely neglect the recommendation what Magento has regarding the modularity, and you may decide to build the layered architecture, not the domain-driven architecture. And it may be. I mean, to be honest, I'm not sure what the extension quality tool will give you. What kind of assessment will be provided?
Yeah,
probably it's not that high, because we at some point of time we decided to enforce same requirement which we have for core developers, for extension developers as well. So that even so that from my perspective, I try to be more democratic here, trying to say that for extension developers, they may extension developers should have a possibility to choose whether they need to have all those requirements or not. Because
that's fair.
Because the vast majority of extensions are not being customized by system integrators, for example, and they're being used but they're not customized a lot. That's why maybe having the same set of requirements is overkill. So that's another good point. So I was trying to be more democratic, but people decided that we need to enforce, and third-party developers should follow our authority in this perspective.
Oh, I understand. I understand.
But because not because we are trying to be so strict, but because when you have one set of rules, it's much easier to spread them to different projects. But if you have different set of rules for third-party developers, different set of rules for us, it's more complex to keep those set of rules and keep up to date and so on and so forth. That's why
it is.
Only from that decision was made only from the maintenance standpoint mostly.
That's really good. Igor, this has been really good. I see we're actually a little over time. I actually might split this into two podcast segments, just because it's literally has been a sip from the fire hose. This has been really good. I've learned a lot. I've taken some notes myself. And this is absolutely fantastic. Really well, like I said, thought out material. You didn't prove me wrong at all. Through how I introduced you just reiterated to everybody who's listening to this just what a genius you are.
I still have some objections regarding that, but
that's fine. You can. I said it, so that's okay. Anyways, thank you for joining this podcast. I am very grateful for this. I have a lot to learn, to digest myself, a lot to think through, because I want to put this into practice, what you've talked about as far as when I'm doing architecture as well. So this is good. Thank you for your time, your effort, and I really appreciate it.
Sure, of course. And and that was still half of my answer to the modularity, because I did not even touch base the MSI, because I believe this is the good practical reference for the modularity and how it might look like. Taking into account that we decided to be very granular.
Yes.
And so it may be, and
I'll have you back. I'll have you back on that, because I agree. There's that system has received some hate as far as like how many modules there are in there and all that stuff. And again, it's about exposing the decisions, the why, like you said, the why as opposed to the how. I think people are going to get a lot of value from that. So, if you're up for it, maybe we should come back together and we'll record another podcast just talking about MSI. How about that?
Sure. And along with MSI, I believe we'll need to make a touch base on regards of the coarse grain API versus fine grain API, because it's very, very related. Because,
yes.
And again, this is the architectural choice, whether you would like to retrieve as much information as possible, or you, contrary to that, you prefer to have a very granular API. And,
that's good, yeah.
Along with the time, the answer and the industry answer is being changed as well. That's why specifically the microservice architecture is getting so popular lately, because microservice architecture specifically is tuned for fine-grained APIs, and like 10 years ago, there was no compute power to make it fairly efficient. Well, now it's possible, so that people started to use it more broadly. And another, I believe, the interesting topic which we'll touch base in the scope of that conversation is what exactly part you would like to substitute. Because, for example,
that's good.
You may consider that you're a headless commerce from the perspective that your front end is completely decoupled, but you also may consider that the specific implementation is a matter, is a variable as well. Like I mentioned previously regarding the search adapter, so that you may consider that you have like Solar implementation or Elasticsearch implementation or even live search implementation, which might be a SaaS service, but along with that you provide some business API, and this business API just abstract away all the specific implementation behind the scenes. So and based on all those requirements, you end up having the specific size of the module, specific numbers of the module, and so on and so forth.
Wow. Yeah, I think we got to have we're gonna have a good conversation about this. So I'll reach back out. We'll get scheduled, and we'll follow up this conversation with another one. Igor, how can people reach you? So if they're or at least follow you, I assume you have Twitter. Where is there any other places you're active?
I want to say that I'm active in community Slack, but maybe I'm less active there right now than I was like 2 years ago. But still, if people ping me and they use handle with my name, I'm trying to provide an answer. So at least periodically, I'm checking community Slack.
Excellent. Okay. Igor, thank you. Thank you very much. This has been an absolute pleasure. I really appreciated this opportunity, and I've learned a lot, and I hope everyone else has learned a lot. So thank you for coming on Smash the Bug.
Sure. All the pleasure is mine. It was a great conversation. Thank you.
Excellent. Thank you for listening to Smash the Bug. It was an absolute pleasure having you here for this segment. We ended up splitting this talk into this conversation into two different pieces. So I am here looking a little bit different than I am in the actual original recording. But nonetheless, I hope that you benefit from this conversation with Igor. He's an absolutely brilliant architect. That's why he earned his title at Adobe. But I hope that you understand what we were talking through. And if you have questions, reach out to me, reach out to him. He's available on Twitter, etc. Learn this platform, learn the ideology behind it, the reasoning behind it, and this will make you a better developer. Thank you for listening to Smash the Bug.